Hey guys! Alright, before I get started, I want to apologize for looking like this. Tommy and I just got back from an 8-mile run, and I wanted to make sure I got this video out tonight, so I went ahead and just started recording like as soon as I got back. So I am not looking my best, but we're going to be learning, so that's what's important. Today our video is going to be about making predictions using data. And we're going to go through a couple different things. We're going to talk about what a population is. We're going to revisit that P in the MVP when we learned about statistical questions. And we are going to talk about what a sample is and how the two different kinds of samples you might get when you survey a population. And then we're going to talk about using the data that we get when we do these surveys and we talk to our populations and we gather our data. What we do with it after it's all gathered and we find the mean, median, mode, and range. All right, so how we use data. Data gives us information about a population. We've kind of already started figuring that out. We've looked at the baseball players. We can look and see, okay, who's a better hitter based on their batting average or the number of home runs. Which team has more home runs on average. We can tell a little bit about the people we're surveying based on the data that we collect. So on the left side of your Cornell notes, you should write how we use data, and on the right side, I want you to write what's in green. We look at the data to make predictions about a population and compare two, sometimes more different populations, okay? All right, so population, again, population goes on the left side of your Cornell notes and the green part goes on the right. A population is individuals, items, or data that you would like to find out information about, okay? So basically, it's something that you want to learn a little bit more about. That P, that population, is the MVP, is the P in MVP. So measurable, variety, and population, this is where that P is coming in. I told you that we would revisit the statistical questions a little bit later. Well, this is when we're doing that. So we're learning about the P part of our statistical questions, the population. Here's the thing. Sometimes populations that we want to learn more about would take too much time to talk to every single person in the population. Like the United States does a census once every 10 years where they ask every single person in the United States certain questions about themselves. How old are you? How many people are living in your house? And the reason that they do that once every 10 years is because it takes a really long time to talk to every single person in the United States. So when we don't want to talk to every single person in our population, no matter what it is, we use a tool called sampling. And on the left side of your Cornell notes, I want you to write sampling, and on the right side, it's when you collect data from a group within the population. So you have this whole population, okay, and you start taking little pieces out of that population and using just their data. And even though you haven't talked to the entire population, you use this little sample of the population to represent the whole entire population. So use this tiny little group to represent the whole population. And there's some good parts to that, and there's some bad parts to that. There's some ways where it can work really well, and some ways where it can't. So my example that I'm giving you is, okay, let's say you wanted to figure out how much money does every person in St. Louis make in a year. You can't go to every single person. As a 6th grade student, Live for Life, you can't go to every single person in St. Louis and ask them how much money they make in a year. It's just not possible. You wouldn't be able to do it in enough time to get yourself some meaningful data. So what you do is you sample the population of people in St. Louis and ask them how much money they make. You just pull out a couple people and talk to them about how much money they make. So here's a little bit of vocabulary. So there's two kinds of samples you're going to learn about. A random sample is when each person or object in the population has an equally likely chance of being selected. It's a fair way to collect data. So an example would be, we used to have these phone books. I don't even know if you guys know what a phone book is, but it was a giant book, and it had the name and phone number of every single person who lived in a city. So a random sample would be like if you just go through the phone book and you call every 5th name and you ask them how much money they made, and then you use that for your data. Or maybe you call every 100th name or the first person on every page, something like that. So that you don't know who you're calling. You don't know what their race is, you don't know what their age is, you don't know where they live, like what neighborhood they live in. You don't know anything about them other than their name and their phone number. So you're not going to be able to skew your data at all. The other part of that would be a bias sample. It's where you pull a group out of the population. You're still pulling this group out of the population, but it does not represent the entire population very well. So an example that I thought of is if you're trying to figure out how much money everyone in St. Louis makes, you would go downtown to an office building like in the middle of a weekday at lunch and ask all these business people how much money they make. Like someone like my little brother who's an accountant and works in like a big high-rise building, you could go there and ask every person in this high-rise building how much money they make. Well, this is a bias sample because you know that they have a job. You know that they have a job where they have to go wear a suit and tie. They probably make a decent amount of money. You know that they are at least working. I mean, you know all this stuff about them that's going to impact your data. So that would be a bias sample. And it doesn't mean that it's a bad way to collect data. It just means that it's different from a random sample. Okay. All right, so now we're talking about making predictions using the data. And this is how we make predictions. So once we gather all this data, we start analyzing it. That's what we've been doing with the mean, median, mode, and range. Okay, so you start analyzing this data. But then what do you do with this analysis? Well, you either look at the pattern in the data, and that we look at when we look at graphs. Graphs are a much easier way to look at the patterns, and we're going to learn about that next unit when we talk about graphing. Or you look at numbers that your data gives you, which of course is our mean, median, mode, and range. We're going to start using the numbers to compare two different populations, okay? So here's an example about how we use populations and numbers to make predictions about our data. You do not have to write this down, okay? I would write down the numbers, but you do not have to write down the whole thing unless you want to. So for example, there are 60 students who take dance classes at Mr. Music School. He surveyed 10 of those students to find out how long they practice every day. The survey was randomly distributed and anonymous. The results of the survey are shown below. The times are in minutes. So this is how much 10 people practiced in dance class, okay, out of 60 students. He didn't want to ask every single student because he thought it might be too much data, so he just asked 10 of them. So what kind of sample is this, and what is the population that we're drawing this sample from? Okay, that's what I want you to try to figure out. You can pause the video, go back, rewind if you want to, but I want you to try to figure out, is this a random sample or a bias sample, and what is the population that we started with? Okay, so the sample is the student surveyed, and it was, of course, a random sample because it says the survey was randomly distributed and it was anonymous. Mr. Music didn't pick his 10 best students or his 10 worst students and see how much they practice because that would probably influence his data. He just randomly picked them. And the population is all the students who took the dance class. So the population that we're drawing this sample from is the whole 60 students, and the sample is just those 10. Okay, so this is the same thing. I want you to find the mean practice time from the sample, just these 10 numbers. So I want you to pause the video, add up all these numbers, and then divide it by 10 because there are 10 numbers here. So find the mean. Okay, so the mean is 27 minutes. Okay, so that's our mean from the sample. Now our question is, do you think that this was a pretty good survey? Do you think that this mean practice time is going to represent his entire class, or did he have a biased sample that's going to make the data skew one way or the other? It's going to say, like the sample might have like 27 minutes, but the rest of the class, everyone in the rest of the class practiced for 50 minutes every day, which would make the class's average higher. Okay, so I want you to predict the practice time of all the students who take the dance class. Predict what the practice time, if we did all 60 kids and added them up, what do you think the mean would be about? And we're estimating here. Okay, so since the mean for the sample is 27 minutes, the mean for the population should be about 27 minutes. He pulled a pretty good number of people out of that. He pulled 10 out of 60. If he had pulled 1 or 2 people and asked them, that probably would not be enough. But because he asked 10 people and he got a pretty nice variety of times, that's probably a pretty good indication of the average time that a student in Mr. Music's class practices their dancing. Okay, so here we're comparing two different populations. So that's predicting the trend of a population, of one population. Now we've got two different populations and we're going to compare them. So here's my example for this. So let's say everyone in 6th grade runs a mile. Everyone in 6th grade at Lift for Life runs a mile. 5 students from the Sharks ran the mile in an average of 8 minutes. So we took the population of all the 6th graders at Lift for Life and we pulled just 5 kids from the Sharks. okay? And we said that they ran an average of 8 minutes. Okay, and then we pulled 5 kids from the orcas, and we said that they ran the mile in an average of 15 minutes. So when you when you add up all their times and divide them, the people from the sharks ran an average of 8 minutes, and the people from the orcas ran an average of 15 minutes. Well, what does this tell you about the orcas? You might say things like they're slow or they're out of shape, which they're not, guys. I just totally use those random classes. Okay, I love my orcas. You might say that they were walking, not running. You can say anything like that. Maybe they were having a bad day. But you have to ask yourself, okay, is this necessarily true? Are we getting a good sample? Are we getting good data with the questions that we're asking and the population in the sample that we're taking? And I want you to kind of think about this and jot it down. I'm not going to give you any answers right now, but I want you to say, why would this be a good sample and why would this be a bad sample? Okay, why would this be a good indication of our data and why would this be a bad indication of what's actually happening in the population? Okay, so I want you to compare these two sharks and orcas and write down maybe what you would do differently if you were actually collecting this data to see which class was, the best at running the mile. Okay? All right, so I will see you guys in class and have a great night. Bye.